Hello, we are back here again with one more new video. Now in this particular video we will be talking about the concept of optical isomerism. Optical isomerism. Right? In the last lecture we had learned about the concept of positional isomer and the chain isomer. In this concept we will be learning about the optical isomerism. See, this is a very important question. You have to mark it down in your notebook. This is a very important question as far as the board exam is concerned, right? Now what is exactly the optical isomerism? You can note it down. The alkyl halides which have same molecular formula and structural formula, same molecular formula and structural formula. See, try to understand. In the optical isomerism, they have the same molecular formula as well as the same structural formula. But the question comes here. But have a different arrangement of atom or group of an atom in a space, and they have a tendency to rotate plane polarized light are called as optical isomers, and the phenomenon is called as optical isomerism. Right? So you have I guess you might have understood the concept. The alkyl halides which have the same molecular formula and structural formula but have a different arrangement of an atom or a group of an atom in a space and have the tendency to rotate plane polarized light are called as optical isomers, and the phenomena is called as the optical isomerism, right? So my dear students, this is what is called as the optical isomerism. This question can be asked in the board exam for 2 marks. Now let's quickly take the example of this, then you will come to know. See, what is a plane polarized light? Plane polarized light is a one kind of a special light that I will explain you in the next lecture, right? So in detail we will see what is the plane polarized light. So when we take a ordinary light and we treat it with the nickel prism, we get the plane polarized light. So that I will teach you in the next period. Now let's take the quickly example of the optical isomerism. So here we are taking the example CH3, CH2CH3 and Cl, HCl, right? So this is the compound. Here I am going to put the mirror in between. So when I put the mirror in between, we get the isomer. That is the stereoisomer. CH2, CH3, and this side here it will be Cl and it will be H, right? So this is nothing but called as the optical isomer. Right? So when you put a mirror in between the two, you can see that this is the left side and this is the right side, right? That is the mirror side. Yeah, let's say this compound is there on the left side and the mirror image is coming on this side. So when you see the mirror image, you can see that the chlorine atom which was there on the right side, it comes here on the left side, and the hydrogen atom which was there on the left side, it comes on the right side. So this mirror images are nothing but called as the optical isomers, right? So you can note down this as an example. Okay, now let's go for the next concept. That is the chiral carbon. Chiral carbon. Now what is this chiral carbon? This is a very, very important concept, my dear students. Chiral carbon, or it is also called as asymmetric carbon. Asymmetric carbon, right? So here in this case, the word chiral, what does the word chiral means? See, chiral is nothing but hand-like. Right? It is a hand-like. The meaning is, that means it is unsymmetrical in a nature. Unsymmetrical in a nature. Now what is hand-like? For example, when I take my hand, one hand, and if I take the other hand, they are nothing but the mirror images of each other. But when I try to superimpose one on the other, you can see that one of my thumb will go on that side and one of the thumb will remain on this side. So this is nothing but called as the hand-like structure. It is unsymmetrical in a nature. That means we can say that they are non-superimposable. Non-superimposable. Imposable, right? Non-superimposable on each other, right? So you have to understand that there are two concepts, that is the symmetry and the unsymmetry. So in short, in a simple, if I want to explain what is symmetry, symmetry is nothing but which is same. Unsymmetry means which is not same. Right? As I gave you the example, if I take my right palm or right hand and put it on my left hand, you can see one of my thumb goes on that side and one of the thumb goes on this side. Right? One thumb will go on the left side, one thumb will go on the right side. So that is said to be the unsymmetry. Right? Now what is the symmetry? There are different kinds of a symmetry. See, that is plane of symmetry. Plane of symmetry. Then center of symmetry, then axis of symmetry, then alternate axis of symmetry, right? So these are nothing but called as the symmetry. But here when we talk about the symmetry of the molecules, the two things are very important, that is the plane of symmetry and the center of symmetry, right? So you will come to know when we take the examples of the particular molecules. Okay, now let's understand what is the chiral carbon in detail. So chiral carbon is also called as, there are different names of the chiral carbon. Number one, it is also called as asymmetric carbon. It is also called as asymmetric carbon. It is also called as chiral center. It is also called as chiral center. Third one, it is also called as stereo center. It is also called as stereo center, right? So these are the different meanings. These are the different meanings of your chiral carbon, or you can say different names of the chiral carbon. What it is called as? It is called as asymmetric carbon. It is also called as chiral center. It is also called as stereo center, right? Okay, so my dear students, let's quickly get to the meaning of the chiral carbon, right? What is the meaning of chiral carbon? See, chiral carbon is Sp3 hybridized carbon. Sp3 hybridized carbon whose valency are completed with 4 different groups. including hydrogen, right? So what is chiral carbon? Chiral carbon is a sp3 hybridized carbon whose valencies are completed with a 4 different groups including carbon, or the other meaning is carbon attached to the 4 different atoms are called as chiral carbon. So this is the other meaning for the chiral carbon. See, chiral carbon is nothing but the carbon which is containing the 4 different groups. We all know that the carbon can form the 4 bonds. Carbon has the valency of a 4. You all know we had learned this concept of the valency in the last year in the valence shell theory, right? So carbon can form the 4 bonds. So whenever the 4 different groups are attached to the carbon, it is said to be the chiral carbon. Now let's take an example of this. Let's say we have a 1 H, we have 1 OH, we have 1 Cl, and we have 1 CH2 CH3, right? So this compound, you can see this is different, this is different, this is different, and this is also different group. So all 4 groups are different. So this becomes your chiral carbon, right? Now this particular chiral carbon is represented by asterisk mark, right? It is represented by the asterisk mark on the carbon. So here you can see I have shown you the asterisk mark, right? So such kind of a asterisk mark is used for the representation of the chiral carbon. So chiral carbon is nothing but whose valencies are completed with the 4 different groups, including one of them will be hydrogen present in the particular carbon, right? Okay, so I hope that you have understood this particular example concept. Let's take the example. Now when we talk about the sp3 hybridization, what kind of a geometry it will be? Whenever the sp3 hybridization is present, it will have a single bond. You all know, जब भी sp3 hybridization होता है तभी क्या होता है? Single bond होता है. Then there will be a tetrahedral geometry. मतलब जो भी कंपाउंड होगा उसका टेट्राहेड्रल ज्योमेट्री होगा. सो लेट्स टेक द एग्जांपल. नाउ C2H5 कार्बन CH3, this particular hydrogen, it will be towards yourself, and this particular chlorine will be on the back side, right? Are you understanding, my dear students? See, try to understand this. I will the hydrogen, this particular wedged hydrogen is on your side and this chlorine is on the back side. So when we take the mirror image of this, you will get such kind of a compound. C2H5 carbon, then this hydrogen, this is the wedged hydrogen which is on your side, and this is the chlorine atom which is on the back side, and then comes the CH3, right? So they are the mirror images of each other. Now this becomes your chiral carbon, this also becomes your chiral carbon, right? Now here in this case, they are optically active compound. Why they are optically active compound? Because they rotate the plane polarized light, right? Because they rotate the plane polarized light, so that is why they are the optically active compounds, and they will be represented by the asterisk mark. Now when you take this particular compound and try to put it on this particular compound, you will see that they are non-superimposable. अगर ये वाला कंपाउंड इस साइड वाला अगर आप लेके यहाँ पे अगर इसके ऊपर इम्पोज करोगे, ऐसे के ऐसे उठा के यहाँ पे इम्पोज करोगे, तो what will happen? See, the chlorine will come here, the hydrogen will go over here, right? Then C2H5 will be coming over at the top, and CH3 will be on this side, right? So are you able to understand? They are non-superimposable. That means they are not fitting on each other. See, the one chlorine atom is this side, one chlorine atom is this side. So chlorine is not fitting on the chlorine. So that becomes the non-superimposable image. Superimposable image means what? The chlorine should fit on the chlorine, hydrogen should fit on the hydrogen, CH3 should fit on the CH3, and C2H5 should fit on the C2H5. That particular image is said to be the superimposable image. But in this case, as they are mirror images and non-superimposable images, that is why we say that they are optically active compounds. So my dear students, I hope that you have understood the concept of chiral carbon, right?